We're live. My guest today is Maghnus Mareneck. He's the co-founder at Skip Protocol, and today we're diving deep into something really interesting that Skip announced recently. That's the Block SDK, which allows projects to have better control over block construction. This is possible because of ABCI++, which we'll also get into, and we'll also talk about the Skip API. I'm also dying to find out why he thinks Cosmos should align with Ethereum, not chart a path away from it. Before we get started, though, make sure to hit the like button, hit the notification bell, and subscribe to get notified when I go live every week. And remember that none of what we discuss here on the Interrupt is investment advice. And if you like this content, please consider sticking with us. We're validating on Evmos, Quicksilver, Osmosis, and Juno. Just look for Interrupt in the after set. My guest, Magmar, is coming up next, right here on the Interrupt. Hello, hello.
Hey, how's it going?
Good, good. Thanks for coming on again.
Yeah, of course.
Yeah, you're now a repeat guest, so you know you can hold that badge proudly if you want. So yeah, it's been really interesting seeing like all this stuff coming out of Skip, and like for me this started at Nebular Summit. You gave a talk there about ABCI++, talking about some of the things that ABCI++ makes possible. I just watched that talk again. It was actually one of the few talks that I sat through at the conference because like, it was on day 2, and I had some time by this point. But I sat through it again, and one thing you said there I thought was really interesting is you said that ABCI++, I'm paraphrasing here, is the reason why we're seeing all these kind of new interesting projects coming into the space like Berachain and DYDX. And I'd like you to maybe unpack that a little bit and explain why that is. And then we can get into Block SDK, which I think is, one of the really important kind of developments here that really I think is pushing the space forward. So,
yeah, sounds good. So, I mean, I sort of take this view that I think is a little bit contrarian. It's not my hot take, so it's not that spicy. Which is people come to Cosmos for the tech, right? And my view has always been, Cosmos has this incredible stack that we've invested, half a decade into building. And it's really the reason why we're going to see most of these larger high PMF protocols in Ethereum come into Cosmos because they need access to the things that it can provide. And I think ABCI++ was a huge step forward in that because it just gives a massive new set of expanded primitives that protocols can use to better tailor their block space and their general application and blockchain to their use case. Right. So in the case of DYDX, like just to like hone in on that one, they were on Starkware, and Starkware, is this hyper fast L2 ecosystem, but it runs a centralized sequencer. Right. And so there's some company that owns the sequencer and owns the order book for DYDX. And if DYDX wants to sort of safely operate their exchange, they needed something a lot more customized and a lot more decentralized in order to sort of like, truly do some of the things they wanted to do, like redistribute rewards back to token holders legally, and then just better tailor their actual sequencer to what they needed to get done. Right. So in their case, they have this like really interesting matching system where, they have to store orders in memory, but then also match them extremely quickly. And ABCI++ allows for a lot more, let's call it like application aware block production that actually gave them the primitives to do that.
Yeah, I think that's the key thing here: application aware block production.
Yeah,
which is a very different paradigm from what we've known, I think, for a long time or understood about block production in crypto, where block production sort of happens separate from the application. And during your talk, you explained this fairly well, right? Where you have an application, let's say in Cosmos, right? That's building where transactions are getting sent to the mempool, a validator grabs those transactions and puts those transactions, assembles those transactions into a block, and then just kind of, I guess the application just verifies that that block is correct, and that's it. There's no other sort of sovereignty that the application happens over the content of that block, how transactions are ordered, what transactions might be free, which transactions might be priority over others, etc. And this allows applications to have a whole lot more sovereignty over their block. Now, this is something that I think is, is it unique to say, is it fair to say that this is uniquely a problem that, that it's a unique problem to Cosmos chains or to application specific chains, and that, doing something similar in, say, Ethereum, where you've got lots of different applications sharing the same block space essentially, and sort of sharing the way blocks are constructed, do the same kind of considerations apply there? Can we do similar things there? How does that compare?
Yeah, it's a great question. So, I mean, another way to just like rephrase, I guess, what happened with ABCI++ is it's sort of like this great unbundling of Tendermint, right? So Tendermint is this very old, it's like the grandfather of all POS systems, proof of stake systems, and it does everything. It was designed to do almost everything. It's the mempool, it does all the gossip, it does all the consensus, like it does so many things. And the idea here is to take some of those pieces out of Tendermint and give it to the application so that they can control it, versus this black box algorithm that nobody wants to touch. Believe me, it's very difficult to understand. Does everything for your application. In terms of whether this is a problem for Ethereum, I think it's less of a problem because Ethereum is so untailored to any specific use case. Its only purpose is to service this massive monolithic generalized VM, that they don't really have any need of doing any application side logic in their, let's say, block production. So in Ethereum, they use MEV-Boost and PBS, which is sort of this method of outsourcing all block production to external actors. And the point of all of that is to sort of generate as much money as possible. But because they don't have like a overarching use case, they want to stay generalized, they don't really have any need for tailoring any part of their block production. The only thing they want to maximize it for is profit. And that's obviously different in the app chain world, where app chains usually have a purpose, right? Osmosis is a DEX, DYDX is an order book, Stride is a liquid staking platform. So in those situations, you have much more need and much more desire to sort of reconstruct your block production in a way that's very specific and better tailors to your use case.
Yeah, app chains for the win. And and what about implications on, because when you said that it's the great unbundling of Tendermint and giving more power to the application, that it kind of sounds, I mean, like if you sort of extend that, extrapolate that, it takes you to a place where consensus is, essentially like does consensus have less, so is consensus less smart basically? And so basically you just like generalize consensus by moving more of that into the application, and doesn't that just sort of leave us, doesn't that push us into the direction of having just generalized consensus and like data availability, or is that not sort of like connected to that?
Yeah, I wouldn't say it's less smart. I actually would say it's more smart, because Tendermint was trying to do things that it just didn't really know how to do, right? So when it did block production, which meant like gathering all the transactions, ordering them, and then submitting them to the application for execution, all it knew about, since it didn't have any awareness of the application, which is by design, they're meant to be separate components, all it knew about was like general transaction bytes. And so it would just order them in a FIFO order, or like a first come, first in, first out, or first come, first serve.
Yeah.
And that's all it could really do, because it didn't know what the transactions were, right? So it had no clue how to actually order them. that's like it's an improvement to Tendermint to be able to give the ordering responsibility over to the application that it's plugged into, and then for Tendermint to focus on the things that it really knows how to do well, which is really consensus. So consensus is this process of sort of like talking to all the different nodes, gathering the different votes, creating proposals, gossiping those around. Those are the things that Tendermint was really, I think, best at. And I don't think the block production piece was actually, it was sort of like a tacked on thing. And I don't think it was really its core capability.
Yeah, I guess that maybe I didn't phrase that correctly. What I meant was that it takes block production away from Tendermint itself. Block production now is a responsibility of the application, and so by taking that away from consensus, doesn't that lead applications to? I mean, doesn't that kind of like commoditize consensus so that you could essentially leverage consensus from different blockchains and maybe like some kind of shared security or maybe some data availability, because it's essentially consensus is just like limited to like its most basic functionality, which is everybody sort of agrees on what's happening in the chain.
Yeah, that's actually a really good point. So I think two things on that. The first thing is technically it doesn't take away the ability for Tendermint to do block production. It still can. It just gives the application priority say. So the way that it works now with ABCI++ is Tendermint can still create a block and it can still order transactions, but then it will pass it to the application to say, hey, does this look correct? Do you want to make any modifications to this ordering? And then the application will pass it back, and then Tendermint will use that as its like de facto ordering. But technically, the application could be dumb and say, hey, whatever you say is fine. And then Tendermint could still do block production. The question about like, does this commoditize consensus, I think is actually quite interesting. I'm sort of the opinion that we should sort of modularize or like separate out the consensus layer more, because I think in the future, I would want Cosmos SDK chains to be able to interact with different consensus protocols like Narwhal or Tusk, like hot stuff, things that are potentially faster or different in some ways. But I think in general, as we move more power into the application layer, it does start to become less important what consensus layer you use and where you post data, which is great for something like Celestia, where, for example, with ABCI++ and all the stuff that we're building on top of it, you can do so much with just a rollup. And then the actual just like, data availability can just be sort of exported. And the reason you can do so much is because things are moving more into execution time versus like in the consensus layer.
Okay, very cool. This is all super fascinating. Um, yeah, so let's talk about the about this block SDK. What does that look like? I mean, for as an application developer, right? Like
Yeah.
you're like, okay, hey, like I want to have better control over my block, I want my application to have better control over how the block is constructed. How does block SDK fit into a vanilla Cosmos application, Cosmos SDK app, and how does it interact with ABCI++ and Tendermint and the app?
Yeah. So, I mean, at a very high level, you can think of a block as like a highway, right? So if you think of a highway, in normal terms, you have different lanes on a highway. You maybe have a lane like the HOV lane where you have to have like high occupancy vehicles. You may have a bus lane. You might have the rightmost lane, which is like the slow lane or the lane where you like exit off. And each of those have a sort of different purpose, and each of those run at different speeds, right? So this was the metaphor that inspired the block SDK. And what I mean by that is we were thinking, hey, you don't want to treat all transactions in a block as the same, right? Some transactions are more important than others. And maybe you want to like maybe applications might want to prioritize those over other forms of transactions. And you may want different rules for transactions in different areas. For example, if I wanted to incentivize new users to use my application, maybe I give fresh accounts their first 5 transactions for free. They don't have to pay gas, right? Or
Yeah.
maybe if you've delegated over certain thresholds, you might want to, sort of give like a cheaper gas option to those users because they're high value to the chain. We don't make those decisions about like what should be free or what shouldn't, or what should be important or what shouldn't, but we did want to give sort of those options to developers in order to like better tailor their application to their user base and then also to their use case. So the block SDK basically does this, right? It's an addition to ABCI++. So ABCI++ gave applications control over their block production. The block SDK gives more granular control over each piece of their block. So they can segment their block into different lanes, each of which have their own rules about what transactions do, which transactions are included, and how they're ordered.
So yeah, so let's talk about some of the use cases here, and the documentation on the website is like lists these. So you talked about for example, prioritizing certain types of transactions. You talked about the ability to say make certain transactions free, and I think this is actually pretty interesting. Like how many times have how many times have you staked all your tokens and then you don't have any tokens left to pay for the fees to unstake those tokens or to do like a redelegation transaction, and it's just like such a nightmare. You've got to buy or like swap some tokens on osmosis, and if that happens on osmosis, then you're kind of screwed, right? Because like you have to like move tokens in from somewhere else. And so if effectively you can make certain types of transactions free, and those would just go in like a separate lane. What are the implications for MEV here? Like at a high level, how would this impact MEVs and say like searchers and things like that?
Yeah, so just to talk a little bit about use cases. So the history of the block SDK is, as Skip, we built MEV solutions, and we still continue to do so. But it's definitely less part of our primary roadmap at this time. But what we realized we kept doing was like sort of naturally building the block SDK in different ways, because different chains we talked to had different requirements. Some wanted Oracle transactions at the top. Some wanted, like LP transactions to be bundled together. Some people are doing frequent batch auctions. And so we saw all these different requirements of having transactions split up across the block. And we were like, why don't we just generalize this into a framework, right? So, you could imagine a block construct, and I think there's an example on the docs, but you could have Oracle transactions at the top in its own lane. Then you could have an MEV auction directly afterwards. Then you could have, like some sort of priority set of transactions that, are dedicated to your application. Maybe it's all the LP transactions. Then you could have like a frequent batch auction using different lanes. And then you could have the bottom dedicated towards like free transactions. So the like what it means for MEV is basically we can sort of better assign the part of the block dedicated towards MEV without it taking up the entire block. And the application can be in more control over where it exists and how much takes place.
Okay, so can you unpack that a little bit, maybe for people who are like still grappling with like the concept of MEV and how it affects applications, especially maybe like from the Cosmos point of view?
Yeah, totally. So the basic idea is there are like profit opportunities within a block, right? So you can imagine it as like, let's say $20 sitting on a table. And then a bunch of people want to sort of, just capture that. And so the best way to generally do that is to run an auction for these opportunities. So if there's $20 on a table, like the normally, like if you have a bunch of people standing around the table, the first person to grab it takes all $20. The idea with the MEV auctions and using Skip is you actually run an auction with a bunch of people, and each one would bid what they're willing to like pay for that opportunity. So you'd imagine if it's $20, people would want to pay, 19.99 because it's still profitable. It's an arbitrage. So the way that that works with the Block SDK is we let anybody submit bids for capturing these opportunities. That auction is run sort of across the different validators, and then finally the winner is selected and then put into like the top slot in the lane that is dedicated for the auction winner. And usually that needs to be very high up in the block because like if you win the opportunity, you want to be the first person to get executed before anybody else does. Is that a good explanation?
Yeah, no, that makes total sense. And then you would want to have maybe like free transactions, and like lower value transactions towards the bottom of the block. Now, like this is essentially so that because block has limited, because blocks are limited in space, right? They have like a limited amount of transactions they can run through. Yeah. You want to prioritize, high value transactions at the top and like lower value transactions at the bottom. Are lanes, so this concept of lanes, right? Like, are they fixed in size? Also, do we say like, okay, this lane can fit say 5 transactions, or like this example of the free transactions for undelegation, right? Are we saying like this lane is like so many bytes, or it can be so many transactions, or it can be like transactions accounting for this value only, or like generating this amount of fees? What's the way, how can people kind of customize these lanes? I think we're having some internet issues here. We'll see if this clears up. I hope everybody can still hear me.
So by default, can you hear me?
Go ahead. I can hear you. Go ahead.
Okay, cool. Yeah. So yeah, by default, developers can sort of like cap this size that lanes can grow to. So for example, if you only wanted free transactions to take up like at the like total gap. All good.
Yeah, I'm sorry. There's a delay, and it's, I don't know why it's happening, but I'm just gonna refresh here. I'm gonna hop out and hop back in. Actually, I can't do that. Otherwise, the live stream stops. Are you still there?
Of course.
Yeah. Are you still there?
Yeah, I'm here.
Okay. Can you hear me?
Yeah.
Okay. Yeah, I think this is better.
Okay.
Yeah, I didn't hear that last part, but I hope it got picked up in live stream. I think my internet's having some connectivity issues. So
yeah, no worries.
So I want to ask you a little bit about like the user experience here. So how does Block SDK, how is it going to impact the user experience in the end? And I mean, for users, I guess there's the obvious thing, right, which is like say free transactions or things like that. But from the perspective of like application performance and these sorts of things, like what are sort of the impacts that Block SDK could have?
Yeah, so I think it just gives more tools to applications to better tailor to their users. So, I mean, obviously a free transaction would be nice. And I think like one of the big use cases there is exactly what you said, which is, one of the super annoying UX things, at least in my opinion, is when you stake all your tokens and you want to unstake and you don't have any of the gas token left because you staked everything, shouldn't applications let you unstake your tokens, or maybe even if you do unstake, they can take a small percentage out of what you unstake as the gas fee. So it allows for a lot more things like that, which I think will just make the interchain easier to use. And in general with gas fees, it's just very hard to use the interchain because having all these separate gas tokens is like a new concept for a lot of users. And so users coming over from ETH and not expecting the fact that they need to have 20 different tokens in order to use all the different chains becomes like a really big deal for them, right? Because they're just used to having Ethereum to use every single application. Other ways that I think it might be, different for users is, hopefully like less congestion. If like a if congestion does come back and becomes a problem again with a bull market, we'll have better ways of segmenting out, spam and have better use case of blocks in generals, or have better like I guess like prioritization. Um, and then yeah, I'd say those are the main things. I think it's really designed for just applications to better do what they're designed to do.
Yeah, no, that makes sense. And yeah, one thing I also wanted to ask, and we talked about this a little bit before the show, is I'd like to get a sense of what are the kind of developments in Ethereum. I know that there's this Pepsi PEPC initiative. I read a little bit of that documentation. It seems pretty complex. Can you unpack that a little bit and maybe give us a sense of how these advancements in Cosmos compare to some of the conversations people are having in the Ethereum space?
Yeah, totally. So Pepsi is sort of a uh, design for proposers or validators to commit to things that are like non-standard, I guess. So it's really like a design for sort of like expressing these out-of-band commitments that can actually go into block production. So if you think of the MEV ecosystem inside of Ethereum, where proposers will commit to proposing or including a certain block that was proposed by a builder, that's a commitment, right? They're saying to the builder ecosystem, okay, thank you for building this extremely high value block with lots of MEV. I promise to commit it, and in return, I receive some money for that, right? And it's a lot of money. It can be, upwards of thousands of dollars or tens of thousands of dollars in the case of Ethereum. So Pepsi allows those commitments to expand to a more generalized set. So you could imagine proposers committing to including certain transactions every single block, right? So maybe like a proposer has a bilateral commitment or bilateral relationship with someone like Chainlink and promises to include all the Oracle transactions towards the top of their block. Or maybe they have a commitment to not censoring OFAC sanctioned addresses, which is not something that any validators would commit to today, but maybe in the future they want to. And they commit to sort of like including any transactions that come from those addresses. You could sort of generalize these commitments to anything. Like a big use case for these commitments would be something like, excuse me, Eigenlayer, where, you know, their whole thing is, well, what if you could ask validators to additionally commit to things that relate to security for rollups, right? So a validator could say, in addition to securing the Ethereum blockchain, I also commit to securing, rollup A that is built on Eigenlayer. And so this way, like the idea is basically validators could have more choice and sort of have a selection of things that they can additionally attest to instead of just block production and be rewarded for that.
Does this work in the context of I mean, does this apply in the context of layer one Ethereum, or is this more for like roll-ups or application specific EVMs? Because in terms of applying sort of similar block construction considerations over like mainnet Ethereum, there's just like so many applications competing in that same block space. Like, would that make sense?
Yeah, so the idea here is for this to apply to L1 Ethereum. But as Ethereum's roadmap is now very roll up and app chain centric, right? So the idea behind this is this would be an improvement to the L1 that would enable the L1 to better facilitate more roll ups and app chains in the future, because it could have just an expanding set of things that it could commit to that would make it would make it easier for roll ups to have
Okay.
security from Ethereum. Um, yeah, better get their transactions in, because I think eventually the way Ethereum is going to go, at least in its current form or on its current trajectory, is we're going to see less transactions and more just giant blobs of data getting posted from all these different rollups where execution is really going to happen.
Yeah, yeah, I think that's probably true in the long term, and as a result, layer one transactions are going to get even more expensive, I guess.
Yeah.
There was this interesting concept in the docs for the Block SDK, which is this idea of a lane app store.
Mhm.
What is that all about?
Yeah, so we were trying to sort of make it fun and relatable in terms of how we build these lanes. And the idea is if you're an application developer or an app chain developer, we'll just give you all of these options of how to construct your block space and try to make it super simple to just plug them together. That's why the block SDK analogy is sort of like all these fun like building blocks that you can just put together, because that's how we think it should feel to build an app chain, right? You have your red block and you want to put that one on top, and then you have your green block and you want to put that below. And so you can construct your block production in a very intuitive way, right? Where you just sort of fit these together. There's a bunch of pre-made pieces, and then you can create your own pieces as well. So we have already implemented like the free lane for free transactions. We have the MEV lane, which is sort of the expansion of our previous product line. And then we also have like a default lane, which is just a lane that will contain any transaction and is usually put at the very end. But then we're implementing and working on right now an EIP 1559 lane. So that's a lane that has the same gas market as Ethereum, which I think is excellent and has proven to be really good. And then we're also going to be building an Oracle lane. We're potentially talking about building a threshold encrypted lane, potentially in collaboration with Fairblocks. And then we have a bunch of others that we want to implement over time.
Super cool, very very interesting, and yeah, I can't wait to see, like how this is going to get implemented, and the interesting kinds of lanes that people are going to build, and maybe make available for other chains to use. It just seems like there's a potential for like a lot of innovation here.
Yeah, like some of the feedback that we got from our partners was uh, we kept hearing this thing, which is like, oh, we tried like all of our customization that we did with using the Cosmos SDK was basically recreating this in some form, but this is just a nicer abstraction to get to that faster. So instead of
Yeah,
having to go into the Cosmos SDK and really change things and making your own fork, you can just use the Block SDK to sort of build in this level of customizability without actually having to modify the core code base.
yeah. And so, does the Block SDK sit as a module in the Cosmos SDK, or where does it sit exactly in the stack?
Yeah, so it's not a module, though it will oftentimes pair with modules. So it's designed to use modules to pair with specific lanes, but
Yeah.
it itself is sort of a plugin into ABCI++ that
Okay.
implements a couple like key functions. So for example, it has a match function, which is when a transaction comes in to match it to which lane it needs to be considered for. It has like an ordering function, so how transactions are ordered within a lane. And then it also has a intra-lane ordering. So which lane should be considered first, and then what's the order overall of all the lanes in the block.
Cool. So when I watched your talk, your Nebula talk before this, there's one aspect of the talk which I thought was really, really cool. I'd like you to expand on here. Is you were talking about ABCI++ and how it could be used to effectively build an oracle on chain. So I'd love for you to unpack that use case and explain how essentially chains can become their own oracles, which is a very different paradigm from, say, Ethereum, where you have to rely on oracle providers like Chainlink in order to get things like price feeds.
Yeah, totally. I mean, honestly, I think ABCI++ had this use case a little bit in mind when it was built. But it's not just ABCI++ that enables this. It's actually something called vote extensions. So, excuse me, vote extensions is actually a Tendermint feature, or I should say a comment feature, which allows for validators to include additional data, arbitrary data about anything when they sign a block. So if you think about how block or consensus works today, a proposer proposes a block and says, "Hey guys, I'd like to commit this. What do you all think?" And then every other validator will say, "Okay, looks good. I will add my vote to this proposal." And so if you inspect the bidders that voted yes for that block, right? And you need over 2/3 in order for that block to actually get committed. The idea with vote extensions is it's literally that. It's an extension to the vote, right? So in addition to voting yes on the block, you say yes, and I'd also like you to think about this piece of data. And it could be anything. It could be an Oracle price feed. It could be data availability. It could be really anything. And that means that that data must be available, and at least 2/3 of it must be considered if the block is to be committed. So you sort of tie the availability of that data in vote extensions to the actual liveness of the chain. So the chain cannot move forward if that data is not available.
Okay,
Yeah.
so you're saying you commit this data, and then the data, the validation of the block is dependent on this data also being accepted by other validators.
That's essentially right. Or the validation of the block is dependent upon that data being sort of included in the proposal, right? Because the data is signed by the vote, and you need over 2/3 of the votes to actually like commit the block. Therefore, you also have 2/3 of the data, right? So you can do a lot with that, right? You can do like a ton of things. And one of the very specific things that you can do is you can actually upload Oracle prices as that additional data.
Looks like we might have lost him again. Oh, looks like lost him. This is not a good internet day, guys. Sorry about that. Hopefully he'll come back in just a second. But yeah, this is all super, super interesting. And I think it opens up tons of new use cases for Cosmos. I mean, if you just think about the lanes aspect, like this use case of being able to execute certain types of transactions in priority, or having free transactions, that just makes it so much easier to onboard new users. You could even say, like a chain that wants to onboard new users could effectively give new addresses, like a couple of free tokens, like a kind of a new user airdrop that could be factored into the tokenomics. These are all really, really interesting use cases that I think people are going to utilize in their chains. So I mean, I think it's good for Cosmos. I mean, it's good for the interchain to have these features and to be able to really excel on the he says one sec, really be at the forefront of user experience. I mean, I think that's one of the things that Cosmos that's so great about Cosmos, is that the user experience is so great. We have transactions that are fast. We have IBC, which makes it very easy and very simple to interoperate with other chains. And now we have these sorts of features that are coming out. And I really want to talk about the Skip API with Maghnus, because the Skip API opens up lots of other use cases and just improves the user experience. I think oftentimes it's good tech is underrated in terms of how it can improve user experience. I mean, of course, we need product designers, we need people who build great products that are easy to use, that are pleasant to use, that don't put unnecessary hurdles in front of people. But in addition to that, there's also the aspect of the technology that allows this to happen. And so Magmar's back, so we're going to go on. Can you hear me?
Hey, Seb.
Yeah. Can you hear me? Can you hear me? Are you there? I can hear you.
Can you hear me?
Yes, I can.
All right. Sorry, I think that was me that time. I just completely know what happened. I had to join. I hope this is okay.
That's fine. Yeah, I mean, this is the worst episode in terms of internet connectivity I've ever had, but probably one of the best in terms of content. So hopefully that makes up for it. But yeah, so we're talking about the Oracle idea, and also so I think you were saying that data gets added. The data gets added to the vote, and that's how we arrive at sort of this Oracle use case. But I'll let you take it from there. Okay, I think we lost him again. We might have to wrap this up if let's try one more time.
Yeah, I don't really know what's going on. My bad.
This seems to work. So I don't know if you heard me there, but basically I'll let you pick up where you left off, which was explaining how we could add arbitrary data into a commitment vote on in a tournament block.
Yeah, exactly. So the way that this works for an Oracle is actually quite simple. So like, I think the example I was trying to give is, let's say your only purpose was to include the Ethereum price and have that be globally available in your blockchain, right? And let's say you're Osmosis. So the idea is basically validators, when they are voting on a proposal and saying, okay, like I like this proposal, let's go ahead and commit it, they will also add to their vote the price of Ethereum that they're observing, let's say via Pyth or via Chainlink or via some other, Oracle. And then they will add that to their vote. And then when the block gets committed, all of those votes need to be available because, you had to have 2/3 plus. And that way the proposer can use all of those prices that were included to actually come up with, let's say, an average or median or some kind of aggregate value of all those prices that were uploaded. And the calculation can be double checked by all the validators. So validators can say, okay, like the expectation is that you have to take the median of all of these. And if you don't, then we're going to vote no on how you executed that block or how you proposed that block.
And what are some of the I mean, what's the kind of edge case where this falls apart? I mean, like, do validators, I guess, have an incentive to vote correctly in terms of the data that's added? But are there any edge cases in where a validator could get away with posting inaccurate data?
So you could always post inaccurate data, and the goal of an Oracle system is to sort of prevent like a single posting of inaccurate data, or even like a couple of validators posting inaccurate data, from completely affecting, or manipulating the actual price. And so the idea here is, I mean, if you take Chainlink as an example, they use a median, right? So they'll have like 20 data reports, and they'll take the median of all of those, which means you have to have over half the validator set manipulate the price in order to affect the median, right? If you have anything less than half the validator set, then technically you shouldn't be able to affect the median, right? So the same thing applies to the vote extensions, right? So if 2/3 of the validators, which is what is required for block production to move forward, vote a certain price or sort of record a certain price, then over half of them have to be dishonest in order for the final price that the blockchain reports to be affected.
I mean, does the application have any say? I mean, in this particular use case, would the application have any say in terms of where validators are getting this data? I mean, because, like, validators just run software, right? So would this kind of like sourcing of the price feed happen in the binary that the validators are running, or a validator is sort of free to go and like get the data from CoinGecko or from Chainlink or from Coinbase if they want to?
Yeah, so I mean, I should preface all this with saying we've actually built an Oracle, and it does all of these things. And the way that we built it was we built a generalized provider interface, but then actually implemented some of them ourselves. So we have one for CoinGecko, we have one for CoinMarketCap, we're building one for Pyth, we're building a Uniswap adapter. But then technically, validators are free to use whatever price feeds they want in addition, right? So they could, source prices from other places as well. But I think like the way that I see this going is the application will define and the binary will define, a set of providers that they expect all the validators to run. Everybody will just run those by default because it's in process, it's within the binary. But then validators technically could add more if they wanted to.
So what does this mean for? I mean, does this make oracles obsolete in Cosmos?
I don't think it makes them obsolete. I would say it makes them actually usable, right? So it was previously quite difficult to pipe in Oracle prices in a way that was actually very safe. And so really what ABCI++ and vote extensions and what we've built does is it allows you to very easily and very safely interact with existing oracles. So this is probably the best way that I can think of to pipe in, let's say, Pyth feeds, right? So if you wanted to, if Mars wanted to use Pyth in order to back its collateral prices, or Osmosis wanted to use Pyth to, expand the set of offerings that it has for its pools, or run some kind of like perpetuals thing, this would be the best way to actually pipe in those prices every block.
Okay.
And it doesn't cost 5% of your token supply, or like $10 million like Chainlink does.
Yeah, I mean, and are any chains using this?
The Oracle that we built?
Yeah, yeah.
We should see a couple chains go live with it. Bear Chain will be using it. Osmosis will be using it. We're talking to Neutron right now. Chatting DYDX, they already have their own Oracle implementation, but potentially they could borrow some ideas from this.
Yeah.
It's really it's not like using an additional service, so to speak. Like the Oracle that we've built is really just an expansion upon vote extensions to turn your own validator set into basically an Oracle network
Hmm.
instead of like productizing some separate chain or separate service like Ojo or Chainlink or whatever else there exists as an external provider of prices.
Okay. Yeah, that's and are you productizing this? I mean, is this how like Skip generates revenue, is by sort of productizing this Oracle product, or I mean any of these products basically? Like, yeah, how does Skip make money?
We get this question a lot. We haven't really focused on monetization. And the reason for that is we've taken such a big bet on Cosmos as a team, that our view is really, encapsulated by this like grow the pie mindset, where the space that we viewed there was like a missing piece was basically like who's the consensus of Cosmos? Who are the people who are building like the really core infrastructure that eventually might make money in some form, but ultimately is just like the building blocks for adding a ton of value to make an ecosystem work. And we're trying to fit ourselves into that bucket. So that fits into the API product too. That is a free service. It doesn't charge any fees. But it's something that we viewed as like a fundamental piece that was missing inside of the IPC ecosystem and made it just way easier for everybody to do cross-chain transfers and swaps and things like that. And so right now we're really just focusing on, what can we build that's missing that makes Cosmos work, and eventually we'll figure out a way where we can be part of the economics of Cosmos actually really making it.
I know you've only got a couple minutes left, but I do want to talk about the API a little bit. So there was this post by Barry on Twitter, I think like a couple days ago, talking about how the API expands, Cosmos outwards into Ethereum and Celestia. Yeah, what is the Skip API like? What's the idea here?
Yeah, the Skip API is very simple. The idea is basically how do we make it really easy to do cross-chain workflows, right? So when you transfer a token over IBC, you usually don't want to go from the chain that you're on to the chain that you want to get to. And that sounds weird, but it's kind of a secret reality of IBC that most tokens are wound in a way that makes them unusable. So for example, if I have Atom on Osmosis, right? So I got Atom on the hub and then I transferred it to Osmosis, and now I want to send it to Juno. Your first thought would be, okay, so let me figure out how I can get it from Osmosis to Juno. The problem is, if you actually did that, the Atom that you send to Juno cannot be used on Juno because at first it needs to get sent back to the hub and then to Juno. Because every time you send an IBC token, it sort of like modifies the token because it modifies the security properties of that token so
Yeah.
that you end up with all these randomized sort of like IBC versions, right? So the API, what it does is basically it figures out what route you need to take. So in that case, it would figure out the route back to the hub and then to Juno. And then it constructs a single transaction that does that all in one click. So then all you need to do via the API is say, here's where I am, here's where I want to get to, figure out the route. I don't care if it's 100 chains or one chain. And then give me one transaction I can sign that gets it all done, right? And in addition, along the path that it takes to actually unwind the token, it can do things along the way, like swap, for example. So now you not only have the routing piece, but you also have the swapping piece. And this is all to sort of enable this final use case that we wanted was any token, any chain to any token, any chain. And we want to expand that to not just be on, IBC connected chains, but also to be on Celestia rollups, to be, with Ethereum L1. And so we'll probably have to use bridges for those like Axelar and, Hyperlane and Wormhole. But we're adding that support right now.
Hmm. And your hot take was that you think that Cosmos should align with Ethereum and not chart a path away from it. Can you unpack that?
Yeah, totally. Also, I can stay till 11:50 since all the connectivity issues.
Okay.
if that's helpful at all. But yeah,
Yeah, yeah.
so the I think like the dominant narrative for Cosmos has always been, we're our own ecosystem. We are sort of a separate ethos. We're very, I don't want to say modular because that's very, Celestia-esque, and I don't want to hijack their narrative, but we're very sovereign, right? So we have a bunch of different app chains that all have their own communities and do their own things, and that is completely different than Ethereum, which is this monolithic monster, right? It's a great monster, but it is huge, right? Um, I think what that's sort of done is chart us on a course that's sort of like away from Ethereum. And I don't think that that's possible anymore. Meaning, like, I don't think we should be charting a course where uh, anything in Cosmos is sort of anti Ethereum, right? Like, I think the reality of the situation right now is all of the users are in Ethereum, all the liquidity is in Ethereum, all the volume is in Ethereum. And we need to be sort of creating a narrative and creating a reality that deploying on Cosmos does not have to be anti Ethereum. And there's more ways for them to interact in ways that are healthy for both. Right. So I think a simple way to do this would be via EigenLayer or some other restaking mechanism, have the ability to secure Cosmos chains with Ethereum. So you could launch a Cosmos SDK chain, IBC connected, even using Tendermint, but ultimately your security is backed by Ethereum, right? And maybe use Ethereum as one of your gas tokens or your only gas token, whichever sort of you decide. I think this would at least be worth like an experiment to see what would this do to the Ethereum community. Like, would it galvanize them to support one of the Cosmos projects, um, just to see like can we get some of that liquidity over and like what's the impact of that?
Yeah, I mean, in conversations recently, I think sort of realized that there's a lot of people I think in the Cosmos ecosystem that think that Cosmos is a destination, right, for liquidity, and I don't think that's necessarily the case, and I think that we need to make it more interesting for liquidity to come into Cosmos. Now, of course, that comes with applications that you can use. Like it comes with good user experience and this sort of thing. But yeah, I agree. I agree that we need to be more aligned, more Ethereum aligned. Now that's hard to say when you're like not an EVM chain um, and sort of incompatible from a interoperability perspective and also from an application sort of execution aspect. You were saying earlier, and I think like some of the people I've talked to recently feel that Cosmos should be more Bitcoin aligned, and I think that's mostly coming. That narrative might be coming from Babylon. Also, Sunny, I think, is really kind of pushing this narrative. What do you think that would look like, and can we be both?
I don't think we can be both. Because I think if we try to do the Bitcoin alignment, if it worked, it would be sick. Like Cosmos would absolutely make it. I mean, it's a gold mine, right? Sunny always uses this analogy, which is why are we all fighting over the silver mine where there's this untouched gold mine that nobody's going after?
Yeah.
Um, I think the problem though is nobody has been successful at this. There's like who has like unlocked the Bitcoin users and the Bitcoin narrative and the Bitcoin alignment? And honestly, like I don't think anyone has succeeded. Like I don't think Stacks or has succeeded. I mean, I think Thorchain has actually made the most progress, but I think it's still been difficult. And so I just think it's kind of a Hail Mary where we either succeed at that and it's great, but like the chances of not being able to figure out like what Bitcoin alignment really means and how to like unlock all that liquidity and all those users is really small, right? I think like it's going to be very difficult. Um, I think there's a couple ideas about how we could do that. I mean, Sunny has been talking about like maybe we have a drive chain that is built and run by the miners, which would allow for sort of a canonical decentralized bridge between, let's say, the hub and Bitcoin. Maybe it
Drive
means
chain. There's a term I haven't heard in at least 6 years.
yeah, exactly. Sonny was trying to explain like BIP signaling to me, and I was sort of like, okay, trying to figure it out. I think there's like a couple things we could try, but I think in attempting to do Bitcoin alignment, we might lose the opportunity to do Ethereum alignment.
Yeah, but I mean, at the same time, there's just like so many chains that are Ethereum aligned or trying to be Ethereum aligned.
Yeah.
Sure, there's this easily accessible silver mine, but everyone's going after that silver mine.
That's true.
Whereas like no one's trying to go after the gold miner has done any. I mean, like people have tried, like, I think Stacks you mentioned way back in the day, there were things like Counterparty and some other like obscure side chains.
Yeah.
None of those things have really worked out. It is a huge challenge. And I think the big challenge there is the big challenge there is getting liquidity to move out of Bitcoin, because essentially like hardcore Bitcoin users will never move their Bitcoin out of Bitcoin, right? They might move it into Celsius or some like ridiculously centralized solution to gain yields, or but moving it on like some other chain is a huge challenge. Yeah, I don't know what the answer is here, but
I mean, if anyone can pull it off, it's probably Sonny. Like I think he just knows the Bitcoin community very well. He's a Bitcoiner himself.
Yeah.
I think it would have to be like a really big ecosystem effort, right? So we all decide that we're going to try this. We understand what it means to be Bitcoin aligned. We talk to Bitcoiners and like the major people in the ecosystem.
We go to Bitcoin Miami.
We go to Bitcoin Miami, which is huge, and obviously a big concession. We just try to figure out like what that means, and then really start to make steps towards that. I think Babylon's a good first step. I'm excited about what they're doing, but I don't think they're wedded to the Cosmos, right? Like Babylon is a Cosmos SDK chain, but I believe that they're going to be working on stuff with other chains as well. Like I think we need something, if we want it to be Cosmos specific and for Cosmos to really own that narrative, we need to find something exclusive that we can offer.
Maybe one final thing here before we wrap up. Thoughts on Cosmos Hub governance and the Cosmos Hub drama.
So it's sort of a love-hate relationship. I mean, the one thing I love about Atom and the Hub is it's truly decentralized, right? It's like an actually decentralized token. It's probably like equivalent to or rivals the decentralization element of Ethereum and Bitcoin.
You mean in terms of distribution?
Distribution, yeah, basically distribution. How that distribution is geographically distributed, all the different kinds of people who hold Atom. That's a really nice thing, and I think it does lead to like tough governance. I do wish that there could be a little bit more like there could be a more active main party that is driving governance and is like highly trusted by the community to make good decisions. Because I think it's very difficult right now for any improvements to the hub to happen, because it's hard to just like coordinate with the current distributed holders of Atom, right? It'd be much easier to coordinate with, let's say one party that really led a lot of the governance processes, like, the Ethereum Foundation and Ethereum.
Yeah. Who do you think that could be? Is it the ICF or, huh?
I think that should be you.
Lol. No, but I mean, I agree. I agree that not that I should be running Cosmos Hub governance. I agree that there's a problem here. I think to some extent, and we could talk about this offline, but to some extent there is, I think there needs to be we need to, like, all interested parties need to sit down and in person. Like, there's just like too much Twitter drama and too much hub like forum post drama. Like, people need to sit down face to face at least once a year and say, okay, like, here are the issues that we have. Like, not, I'm talking before even we like come to some sort of like stable governance system. It's like, okay, here are the issues. What's the vision? What do we align with? Like, what are the different kind of like factions, and like work stuff out in a face-to-face way. So I don't know if this is like a workshop or, you know, like we all meet at Cosmoverse or something like that, and like we kind of sit down and work things through. Because, you know, you mentioned, like, and you're right, like, contrary to the Ethereum Foundation, where there's a lot of like top-down decision making, and then the rest of the ecosystem sort of like goes with it, or at least like the Ethereum Foundation seeds a lot of ideas, which then the rest of the community can kind of like debate and sort of grapple with. There isn't that in Cosmos, and so we need to find other ways to have that like kind of like human governance aspect first, that human human consensus, in order to move forward. And I think the first thing, you know, Elijah like put out this post on from Duality, put out this post on the Cosmos Hub forum about how we fix governance, and I think like that's the first thing that needs to happen. It's like aligning on what the vision is for the hub, and then coming up with like a governance model that can work, right?
Yeah, I mean, we tried that. It didn't happen. I think one thing that, yeah, I don't know. I honestly don't know. I mean, I think like the reality of like the Atom 2.0 failing was a lot of the people, I mean, you know, Sam Hart mainly, like left, right? And you know, it was too difficult to sort of go through that entire process and have it fail. And you know, I think we need a better process by which, you know, if we do that again and we really make another big effort as a community, like we have to make sure it's something that doesn't fail.
Yeah, but yes, and also, you know, when they did Atom 2.0, I don't get the feel. I didn't get the feeling like, and I think a lot of people did get the feeling like there was an inclusive conversation to be had, right? The inclusive conversation happened after the white paper was announced. And I think that was one of the big mistakes. It's one of the things that we talked here on the podcast quite a bit at that time, is that the optics of how it was presented were not great. You know, I often say that like if Zaki would have just had like a big draft across his presentation, that would have changed the odds of Atom 2.0 passing tremendously. But I think the process of getting to Atom 2.0, you know, was still a fairly insider process, right? There were maybe like a dozen people involved in this process.
Yeah,
I'm talking about bringing together maybe like 100 or 200 people, maybe not 200, but like somewhere in the vicinity of like 100 to 150 people, and in a setting where all ideas can be heard, where people can make proposals, where we have debates, where we have conversations, where we sort of like work and research on different things. And then at the end of that, like come up with some recommendations that then we go on and like work on some more, maybe at like another event or like offline or this sort of thing.
Yeah,
I think this sort of more collaborative way of going about things would work better. Anyway, my camera's dropping off now, so this is officially the worst technical podcast I've ever done, worst podcast I've ever done from a technical perspective, but an interesting one nonetheless. So we're gonna leave it there, and hopefully our internet gets better for the next one.
Thanks, Seth.
Maghnus, thank you for joining me once again here on the Interop, and look forward to chatting soon.
See you, Seb. Thanks, everybody.
Cheers.
See ya.